morning when I wake up, I had today 12 degrees inside temperature. The nice thing about this, you have to do it only once a day. Fill it up, then start it. The heat goes to the floor. It's a hydronic heating. You can see now it has 16 degrees. 15. Yeah, it's a bit loaded from yesterday. When I'm not there, it's getting down to 10 degrees. So, the oven, it's still cold. Yeah, 47, it's heating up. Now, yeah, 19 degrees, 20. And in 2 hours it's warm. That's the bad thing, it takes 2 hours to get warm. The good thing is it stays warm once it is. So now drinking my coffee like every morning and I'm done. The house is warm then the whole day till the next morning, even it's freezing outside. Wood likes to combust with a high temperature. Even it's not the wood that it's burning, it's the gases that's getting out of the wood. So I would like to make it a top-down burner. It means it's gases out on the top and burns at the bottom. But that's, I have to twist down the wood stove, and it's quite difficult to build and to start up. So I live with the low efficiency of that, and it's just temporary use. And now we have here at the, it's going up to 500 degrees. Wow, that's really hot. Oh. Yeah, 300. That's optimal temperature. That's full. Yeah, that's the advantage of wood. It's burning quite heavily, or you should let it. And that's not the wood that's burning, it's the gases that comes out of the wood. So before I had the water pipes in there, it goes up to glowing red. Then I put it full of wood and let it burn. And that means it has 600 degrees up to. Now it's not, it's just burning. That's the next problem. I reduced the draft from the furnace because of the concrete there. It's cool. I need to clean it, remember me. And the water who sucks out the heat. So we have not enough draft of air. And that's why it's not burning all that. Not with that high temperature, because it don't sucks enough air in it. That's one problem we have here, and that's due to the fact that the temperature of the exit of the furnace is quite low, 50 degrees, 60. The wall only has 40 degrees. In the center I can go up and measure, but it's difficult on the roof with 2 hands. The boiling noise you hear, it's from the middle, it's from the deflector. I can open it. Yeah, I put on that. I need to make that tooth go to the top. As you can see the pipes in there. Stainless steel pipes. And the noise coming from the edges where that about, yeah, it's, you can see there is no black thing on it. That means that it's over 600 degrees hot, so that the carbon on it burns. That's not the fact to all. It comes out a bit from the bottom layer, but this is how it works. And you see the walls is they glint. That means tar. There are tar on them. That's a bad thing because the temperature is too low. Get that out. Okay, that's the wood stove. One of the important things about wood, let it burn with high temperature. As you can see here, there's not much coming out of the furnace. The temperature at the top is about 50 degrees. The furnace has about 35 degrees, and that's almost steam and a little bit of smoke. But as you can see, it's almost nothing, undetectable, not to smell. For that you need high combustion temperatures. That's quite important. Don't throttle wood fire down. And here's the technique we're using for that. There we have it's dirty and cheap build. That's the 10 euro water pump from China. It's working now for 3 years. That's the quick and dirty connection. Oh shit. Yeah, we have about 45 degrees. It's really burning quite hot. So if you mix, that's the furnace. It's made of stones that you concrete blocks that you normally use for floor, like this one we have here. You can get them quite cheap, and they even store a lot of heat. That was my first idea about all of that, to store the heat in that concrete. It works quite well. It's getting hot in here. It's for the back, and it's heating up that room normally before I put on the hydronic heating. I used that. It worked, yeah, quite well, but I have to go up once in the night when it was really cold. So to come back, there's one really important thing. If you mix fire with water, you get an explosion, and you could get a steam explosion. The temperatures and the pressure that's built up, it's quite good. So you have to install a safety, and this is that. It's just a bottle connected with a hose and cut the bottom out. Here's the top. So if the pressure it's open to the atmosphere, we call it open heating system. So there you have the problem of permanently getting air into the systems, and that means you have corrosion. But that's not a problem. That's why I use these hoses and only copper and plastics, because you have no rust problems with that. So now I'm going to that's another one that's quite dirty. You don't do that, but it was the quick and dirty version. I already have the stainless steel plate here. It's there, and the pipe is there as well. That's the next thing I do. It's to pull on the electric heater out and the heat exchanger in. It goes for the geothermal as well as for the wood, or maybe the wood is then out and I don't have to do it. So now we do the dirty one and connect that's what you normally don't do, but we connect now the heating directly to the warm water. I wouldn't suggest it for drinking water, but for the shower it's more complicated because you breathe in that water and you that's not good. You can, yeah. So now it's ice cold, but we are getting now, yes, warm in, cold out. Yeah, cold out. That's connected, and if we want to get real hot, check. So, yeah, that's it. But we have for that, where you got it. So we have a temperature control rail here already. That will do that job later on. But as you can see here, it's the quick and dirty version of all of that. And we have another problem now, because we're heating up now that water, the water expands and it will overflow that. So we drop the water level. That's one problem of our open system. Yeah, and as you can see, you can control the ratio of water by changing the voltage of that pump. We have now 3 watts at 6 volts. We can up to 12 volts, and then we have 12 watts. 1 ampere it's drawing, but it's no needed. No need to do, because we have a good and high spread here for the boiler has no hydraulic resistance, but the floor heating has a quite big, and we have only 1 circuit. If you have bigger areas, that's the important thing. Use short pipe and more parallel connect them. Don't use one long. You don't get enough water through that. If you connect it to a stove, a wood stove, that's quite important. You have to get rid of that heat. It's coming out in a short period of time and quite heavily. Connect parallel pipes, short ones, and put them put them together in about 5 centimeters per pipe, so you can get all that heat coming out of the stove into the floor. If you don't do that, you will end up with great temperature spread between that 2 pipes, in and out, and boiling up that. I can achieve that too if I put it full of wood, dry wood, and take it with 3 watts, but I can switch up if I want to. But there's another problem here with the quick and dirty. I don't have a temperature control on it, so it's not good if you're getting cold water into the stove. It's building black up. Here's the temperature valve. We've got it already there. Yeah, I do that when I finished with the geothermal system.